Now we will present on storage. Storage and memory key characteristics. First, we have speed, or how fast data can be accessed to read and write. Capacity, which is how much data can be stored. Physical size, which is physically how big or how heavy is the storage unit. Volatility, which is if it loses data without power. Power, which is how efficient is it with power and heat. And cost, which is how expensive is it per unit of data stored.
We have a lot of type of memory devices in the physical world. We have solid state memory, which means that the memory is remembered through electrical contact. These are registers, RAM, and ROM. We have flash drives, which are USBs, CF cards, and SD cards. Something like this. We have SSDs, which are called solid state drives, and they are like this. We have magnetic disks, which are like hard drives. We have optical drives, which are like your CDs and DVDs. These can store massive data such as movies and other types of long footage, as well as magnetic tape, as you can see right here. The thing with magnetic tape is that it is used in long-term archival storage.
Here we have volatility. If we say that memory is volatile, we mean that it will forget everything when it is turned off, or that we will lose data when the device loses power. If it is non-volatile, we mean that everything will be remembered even if the device is turned off, or that we will not lose data even if we lose power. An example of this is that having tabs open in browsers. That is volatile as because when we lose power, we lose all the tabs. However, on the files on the device, these are non-volatile because even when we lose power, the files are still stored. Here are some examples of volatile. We have CPU registers, CPU cache, and the main memory RAM. And then we have non-volatile, which is magnetic tape and solid state disk. We have the somewhat of a trade-off for capacity, which is volatile devices or volatile is a lot more fast, but the capacity is very low. However, with non-volatile, it is very slow, but the capacity is very high. Here we have RAM. RAM is the main computer memory. It is volatile, so it forgets everything or it loses all the data when the device loses power. A modern computer might have anywhere from 4 GB to 32 GB of memory.
So here are hard drives. Hard drives have a huge capacity, generally between 2 to 18 terabytes. It's non-volatile and most times interfaces with SATA. Its access time, however, is very slow, about 4 to 12 milliseconds. And you need to account for the rotational latency. Rotational latency basically means, let's say the data you're accessing is right here or right here, and your pin header is right here. It's looking for that data until you circle around the entire disk, then it will say it found the data. Speed of the platter is, or this metal reflective platter, is anywhere between 5,400 to 7,200 RPM. it has its own internal cache size of about 32 megabytes, and it has a throughput of 150 megabytes per second. It is very unreliable because it is very sensitive for physical movement. During transportation, the disk can be damaged, which affects the performance of the drive. SSDs or solid state disks, solid state drives use an IC or integrated circuit to store the data using electrical contact. So that means that it runs very silently and is resistant to physical movement. This too interfaces with the SATA. It has a much quicker access time. It's almost zero, and there's no latency. It's very expensive though for large sizes of SSDs compared to hard drives. It's very expensive, and charge will leak. So the electricity will leak out, and if not used persistently, the data will leak out because there's no more electricity to store the data. So it is a not suitable it is not suitable for long-term storage. So here is a graph or a table showing the differences between an SSD and a hard drive. So this speed is a throughput basically means that it how many bytes megabits per second it can put out. So this throughput or speed of this drive is 269 megabits per second with a 4 millisecond latency, while the speed or throughput of the SSD is about 2,000 megabytes per second with a 0.2 millisecond latency. So in speed wise, it is very much faster, the SSD, compared to the hard disk drive. When you come to capacity, the hard drive has 18 terabytes, which is not comparable to the mere 7.68 terabytes from the SSD. Physically, however, the hard drive is more heavier and more bulkier compared to the SSD. They both draw about the same amount of power, 5 watts and 6 watts, but the cost is much cheaper for the hard drive compared to the SSD.
So here, finally, we reached the end of our first computer science lesson. We wanted to commend you guys as there was a lot of slides, which is 35 whole slides about computer architecture, and that is a lot of information. However, this is definitely something that we are commending you guys for doing.
I know it's a lot, but you all did great.